Now, a couple of things. First, let me hit this announcement. Math team, as far as I know, is still meeting Fridays at 12 noon on the Birmingham campus, and Monday at 3 p.m.
on
the
this
Birmingham campus in C100.
Oh, no, I have two marks on the page. I'm sorry. I didn't erase one of the marks.
Yes, sir.
We're right at the beginning.
I'm sorry?
Right. This is right where we start here.
Ms. Smith?
Okay.
Biology instructor?
4.6, page 310.
Smith?
Okay, I think we did the little introductory thing, but here it says, this is that first paragraph.
What's that?
Almost. We know that the tangent function applies. Do we really know that?
Pre-calculus trick?
Alpha minus x
Math
is always
113?
minus alpha of x. That's true for tangent.
Oh, Dr. Thomas. Okay.
Tangent negative x, where all the negative tangent. Anyway, so whatever you do over here, you put the opposite over there. Now, consequently, the graph of y is equal to tangent x is symmetric with respect to the origin, meaning that what you see on here is down here with respect to the origin. You know from the identity function, and this is the ratio of the quotient identity, that tan x is equal to sin x over cosine x. Now, if you, I don't know if you've done this, that's just a little sin you know is the odd function. Cosine is the even function.
Classes, but he doesn't know his math teacher's name. That doesn't make me feel too good. Y'all know my name, don't you? Okay, good. Thank you so much.
But you also know
all right,
that
Sarah.
therefore is undefined.
Okay, that's fine.
Where is cosine zero?
First name's Charles, right? And last name's Fowler. Okay, so let's start back over. All right, math team meets on the Birmingham campus Fridays at 12 noon in C100, and Mondays at 3 in C100. Now, once I get through treatments and stuff and am able to, I'll be glad to meet with you anytime on this campus if you're interested in doing it. Now, we wound up missing 2 classes. All right. And this is Jared, right? Okay. All right, good attendance today.
All right.
And I don't know, did all of you get messages in time, or did you show up? Okay, a few. You did. Okay, sorry about that. I had treatments Thursday and Friday. That's why I wasn't here Thursday, and I had planned to make up for that on Tuesday, because now way back, I think it was 2008 or 9 when I started treatments, and that was a pretty rugged chemotherapy. That pretty much wiped me out. But then since then, I've been on 2 other drugs, and basically after the day of the treatment, I didn't really feel much of anything. Okay. This one, goodness gracious, this is a new one I started this time. I mean, the weekend wasn't so awfully bad. I was just a little tired. But Monday morning, I just went right back to bed and slept for another hour, then drugged myself here, taught my 2 classes, and drugged myself back home. And I thought, well, it'll be better on Tuesday. Well, I got up, I showered, I ate breakfast, went down, and I just sat down on the sofa. I said, I don't feel like I can safely drive to work. I mean, I felt that rotten. And my wife said, you know, she's an epidemiologist and she knows diseases, and she says there are 2 different strains of flu going around now. There's another virus that's going around now. Any one of those can land you in the hospital when you're healthy. You don't need to be out there. So I went back to bed and literally went back to bed. And
here is when you go from
I never sleep in the daytime.
X equals negative pi half. The positive
got up and ate breakfast, and then it was so pretty. I went outside with the dog and sat in a lounge chair outside in the sunshine. Fell asleep again. I never can sleep in the daytime, especially outside. So the dog loved it, but you know. Anyway, And so I thought maybe after that now, I'd come in and do that makeup.
15708.
We're going to do it at 3:30.
If you drop the one,
I was really seriously considering it. And then, and my wife had checked to see what the side effects of this drug was. Extreme fatigue. I had it. I mean, extreme fatigue. And then one of the other side effects showed up later that afternoon. And, sorry about this, severe diarrhea. So I said, I'm glad I didn't go in and do the second class. I would have been driving in and went, ah! So I couldn't do it. And then yesterday, I came in a little late, taught my 2 classes. I felt much better yesterday.
Here are the key points.
And so far, good today, except when I left home this morning, I got to Red Mountain Expressway. I mean, on the Red Mountain Expressway, going to get on 2059, coming to Bessemer. Dead standstill, the ramp to get on. I just had time to pull off and try to go through downtown and get on later. They've done so much construction downtown, the first 2 places I went to, the roads were closed. So I couldn't get on either of those ramps. So then I had to go a big circle around because all of them one-way streets down there. Came back around and headed on out. I saw the expressway again, still backed up at a standstill. So I kept on coming. And then the next place I could have gotten on, well, I thought I could get on, there was no entrance ramp there. So I couldn't get on there. I said, I give up. I'm just going to drive surface streets on coming in. So, and they were slow, very slow, because everybody was off the expressway onto the surface streets, you know. So it was really slow. And I finally got in, but I was here at least a half hour late. So as soon as this class is over, I'll make up my Math 112, half of the class. I got half of it done after I got here, and now I'll do the other half after this class is over. And here's what I decided to do with them. I'm going to have to do it with y'all too. Okay. I'm on YouTube video now. This was the last class we had last Tuesday. Okay? Section 4.3. Okay? Now, that's the last one. This is at the end of the playlist. This is video number 29. All
those are going to be our key points.
Okay? So what I had planned to make up the videos, now I'm 2 classes behind in here, 3 classes behind in my 112, and I don't think I can make them up today. So what I'm going to have to ask you to do is this. Okay, go to the top of the playlist. Have y'all been to YouTube yet? You go to Blackboard, under Content, and under Content you'll see a bunch of stuff, the syllabus, research paper instructions, my locator card, all the PowerPoints, and then some of the websites I found or other students have found and recommended. And then finally
already
one that says
Math
113 YouTube videos. You click on that. I think it may be the very last thing under Content. Click on that and you'll get to this, okay? And I don't know how it looks from your side, but it'll be something like that. When you go to the top here, notice we did last time. Let me go down. Why is, oh, there it goes. Remember last time we went to 4.3, and that's what we're working on. If you go to the top up here, not quite at the top, here we go. There's 4.3 to 4.4, and there's 4.4. Those are the 2 classes we missed. Okay? So where we'll start today is, and why don't you do 4.3, 4.4, 4.4, and 4.4, 4.5. What we'll start at today is 4.5. Can you all handle that just doing on YouTube videos? Because I don't think I can have the stamina to do it.
And what's more, they're reciprocal to sine and cosine.
And I don't know. So I'm hoping it's not going to be as bad next week. Okay?
They repeat themselves.
Watch out. Check your Blackboard before you come to class. I know I made fun of it at the beginning of the term. I didn't like that. It's now going to be pretty necessary for you to do. Okay. So if you'll go to those 3 videos, again, they're 6, 7, and 8, 4.3.4, 4.4, and 4.4.5. Actually, today we'll start at 4.5, so you don't have to do all of that one. All right, so I'm going to get out of this then.
Pi.
And
So tangent and cotangent. Repeat.
whew, goodness, I'm tired. Okay. So this is 4-3. So I'm going in 4-3 and go to 4-5. And we'll start afresh at 4-5. Now, remember I said we would have the test at the end of 4-4, which we would have finished on Tuesday had I been here on Tuesday. So I don't have it run off. I have it made out, but I don't have it run off. So at the end of class today, I'll run down and make up the copies of the test. 4-1 to 4-4, first test, take-home test, and you can go from there. Okay. So let's start the slideshow. What's that? I'll give it today. And if there's stuff on there you don't understand, bring it in Tuesday. I hope to be here, and I'll answer any questions you have on the test. I won't work the problems, but find anything in the book similar to that, and I'll be glad to work those.
And it's due
A week from today.
Okay.
But if you need more time, you can take more time, because I know it's been sort of weird. Okay. All right. Any questions? Okay. So what we're going to do, Chapter 4 is still trigonometry, the measurement of triangles. 4.5 is graphs of the sine and cosine functions. 4.6 will be the graphs of the other trig functions, and then 4.7 and 4.8 will be the last two sections in here. That'll be on the next test. So let me get where we are in the book. And okay, let me also say this. You know how every example in the text is followed by a checkpoint, and the checkpoints are all at larsonprecalculus.com. Use it, okay? And every one of the homework exercises, 4.3 or 4.4 exercises, all the odd numbers are at calcchat.com. Use that. And then certain ones in each section are at calcview.com, and they have even more video and tutorial support there. Okay, so that's 4.3 and 4.4, which we would have done had we met the last two times. So let's start with 4.5. Okay? Here are the objectives for 4.5. Still not 100% of this apply. I couldn't make up all these classes today. We'll be sketching the graphs of the basic sine and cosine functions. We will use characteristics of those graphs, two of those being amplitude and period, to help us sketch the graphs of the sine and cosine functions. Then we'll do translations of those functions, horizontal translations and vertical translations. Y'all remember that from 112? You did that with other things. We'll do it with sine and cosine. And then we'll use the sine and cosine functions to model some real-life type data. That's going to be the fun part, right? Okay. So let's look at the basic sine and cosine curves. In this section, we'll study techniques for sketching the graphs of the sine and cosine functions. And the graph of a sine function is also often called a sine curve. The graph of a cosine function would be a cosine curve. And frankly, they look very, very similar. Okay? They just start at different locations, but other than that, they're the same. Now, the combination of the two, sines and cosines, are often called sinusoidal curves. Where that name comes from, I'm not really sure. Probably Greek or something like that. The sinusoidal curves. Again, they look so similar, they just usually classify them as one type of curve. Okay? Now, this figure here, the black portion shows, represents one period. Now, we haven't defined, yes, we did. We talked about period before. One period of the function, also called one cycle of the sine curve. Okay? It goes through this, and then it repeats itself, and then it repeats itself, and then it repeats itself, and then it repeats itself. And going this way, it repeats itself, and repeats itself, and repeats itself. That's the sine curve. Okay? Now, the gray portion indicates that that basic sine curve repeats itself infinitely to the left and infinitely to the right. Here's the characteristics of the sine curve when you look at it. Sine of 0 is 0, remember? Because it's the y value, okay? Now, this sort of gripes me a little bit, okay? When I'm dealing with sines and cosines, I don't like to use x's and y's anymore. I'd rather use theta, and that could be a y or something else, okay? But these to me are angles, not x's, okay? X's are usually used for numbers. These are numbers, they're perfectly fine numbers, but they're also angles. So I would like to use theta down there rather than x and y. Maybe you can name it something other than y. But they're using y is equal to sine x. Just get used to it. The unit circle, the xy's are different from these xy's. They relate to each other, but they're different. Sine of 0 is 0. Sine of pi halves is 1. Sine of of pi is 0. 3 halves pi is negative 1. And 2 pi is 1. 0 again. You go through one cycle, and that's 0 to 2 pi. That's called one period. 0 to 2 pi for your sine function. Now notice here, the range here of your sine function, the domain, all real numbers. All real numbers. Usually I think of them as angles, but they're real numbers as well. The range, though, always stays between plus and minus 1. It goes down to minus 1, goes up to plus 1, but it never exceeds minus 1, below minus 1, or anything above positive 1. Sine is that way, okay? So get used to how this looks. To me, when I do things with trig functions later, I always picture the graphs because it helps me remind myself what values to expect. Now, also remember this. First quadrant was 0 to 2 pi halves. Positive there. Sine is positive in the second quadrant, negative in the third, and negative in the fourth. Same type thing we did before, but now you see it in this kind of graph rather than on this unit circle. Make sense? Okay. Now, how about the cosine curve? The difference with the cosine curve, cosine of 0 is 1 because it's the x value. And cosine of 0 on the unit circle is over here, the value being 1. So it starts up here at 1. At pi halves, it's down to 0. Pi, it's negative 1. 3 halves pi is 0 again. And 2 pi is back where it started with. So the cosine curve also has a period of 2 pi. Because after 2 pi, it repeats itself, and repeats itself, and repeats itself, and repeats itself, and going in this direction repeats itself, and repeats itself, and repeats itself forever. That's what makes them periodic functions. The smallest increment over where everything repeats is called one period. Okay? Now, picture these two. This domain, all real numbers, all real angles, okay, theta, okay? The range from minus 1 to plus 1. The only difference between the sine and the cosine function, if you took this cosine function, shifted it pi halves to the left, that would look just like the sine. Just like it. That's what we call these sinusoidal curves. They're like sines or cosines. They basically have the same shape, same characteristics. It's just the starting points are different. Sine starts at 0, cosine starts at 1. And remember cosine 2, first quadrant, everything's positive. Cosine is negative in the second quadrant, negative in the third, and positive in the fourth. Just like we have seen before. Now, a couple of other things. These are always smooth functions, sines and cosines, smooth. Don't ever put points down there. You know, it's a smooth curve and a smooth curve, okay? Number 2, they're continuous. No breaks anywhere in sine or cosine functions.
The rest of them, yes, you have breaks. Sines and cosines, you do not.
Smooth and continuous functions. All right.
We know that the domain of the sine and cosine function is set of all real numbers. Positive infinity, negative infinity to positive infinity. All real numbers. Moreover, the range of these is always the interval, I say always, we'll get to exceptions for this later, -1 to 1. It is for the y is equal to sine x and y is equal to cosine x, they're always good from -1 to 1. Brackets here, meaning it includes -1 and includes +1. These endpoints down here are included. Okay? Each of these has a period of 2 pi. When it's sine x or cosine x, period of 2 pi. And it says, do you see this information is consistent with the basic graphs shown in these two? They're just repeating those two graphs. Domains all real numbers for both of them, range between plus and -1 for both of them, and smooth and continuous functions. Period, 2 pi, period, 2 pi. Okay. Now, let me say this about the period. Here, sine is 0. Well, here sine is 0. Does that mean the period is pi? No, because here the function is 0 but going upward, here it's 0 but going downward. What makes it 2 pi, here it's going upward at 0, here it's going upward at 0. It must be at the same value going in the same direction. Okay? For cosine, here it's 1, there it's 1. Yeah, that's 1 period. Okay? Because it's going down here and down there. So, yes, that's again 1 period of 2 pi.
Does that make sense? All right.
Note that in those two figures, the sine curve is symmetric with respect to the origin. Okay? In other words, whatever you go to the right a little bit, you go up, you go left a little bit, you go that same distance down that you went up before. That makes it what kind of function? Odd function, exactly. Whereas the cosine, you go a little bit to the right, you're up here, go the same distance to the left, you're still up there. That makes it an even function. Okay? So sines are odds, cosines are even. Other than that, except for that little bit of a shift there, they're almost identical functions. It's just the starting points are different. Okay. So the sine curve is symmetric with respect to the origin, whereas the cosine curve is symmetric with respect to the y-axis. Okay? Those properties of symmetry follow the fact that sine is odd, cosine is even. Okay. Make sense? All right. So to sketch the graphs of the basic sine and cosine functions by hand, which we love to do, it helps to note, and by the way, if you haven't noticed about this book, they love graphing. Okay? Everything is graphed. It helps to note the 5 key points. Okay? In one period of each graph. Those key points are the intercepts, that's x's and y intercepts, the maximum points, and the minimum points. Okay? So let's start with the sine function. Okay, the sine function is x and y intercept is at 0, 0. That's where it starts. It crosses the x-axis here, crosses the y-axis here. 0, 0. Maximum point is at pi halves, 1/4 period, and that is pi halves, it's at maximum of 1. Go another quarter period to a half a period, and it's back down to 0. Another x-intercept. Okay? There's only one y-intercept, but there's an infinite number of x-intercepts. So at pi, you're back at 0, but this time you're going downhill, here you're going uphill. Okay? So going down from here, 3/4 of a period, you're down to -1. That's a minimum. Okay? And then when you get back to 1 period later, full period later, from 0 to 2 pi, that's a period, you're back at 0 again, everything repeats itself from there. So there you have another intercept, x-intercept. So you have, for a sine function, 1 period, 3 x-intercepts, one of those is also y-intercept, and you have a maximum and a minimum. Okay?
Now for the cosine function, again, the shape is just about the same, it's just where it begins. It starts at its maximum, 0, 1, okay? Goes down to the intercept here, and this, by the way, is also the y-intercept, but it's also the maximum value, okay? This is the first x-intercept at pi halves 0, that's at the quarter period, and then the minimum is down here at half a period, the intercept again, 3 halves 0 at the 3/4 period, and back at the maximum at 1 full period later. Now, I'm going to jump ahead a little bit and tell you. Notice a quarter period, half period, 3/4 period, full period. They say 5 key points, but really it's 4 because this one's always the same as that one. So basically, the first thing we're going to do later is once you've determined what the period of the function is. Sine and cosine, what's the period? 2 pi. Divide that by 4. And 1/4 of 2 pi is? Half a pi, exactly. And that's always going to be where I plot my x values. 0 pi has pi, 3 has pi, 2 pi. 0 pi has 3 has pi, 3 has pi, 2 pi. That's where you begin. Those are your key points. So once you determine the period, divide by 4. Always. Those are going to be the 2 points. Okay? So let's do example 1. Now, I kind of don't like this example because they haven't identified a few things for you, but we'll still live with it, I guess. Okay? Let me get my pen activated. I wish I could get myself activated. I feel so lousy. Okay. So sketch the graph of y is equal to 2 sine x on the interval from negative pi to 4 pi. Okay, so I'm going to do my vertical there and my horizontal here, close to horizontal. That's going to be the origin. And let's do this to be negative pi, 2 pi, 3 pi, goodness gracious, I didn't leave enough room, did I? 4 pi. Not quite evenly spaced, but close enough, right? Okay. Now, again, what is your period for sine x, generally? Second? 2 pi. Take that 2 pi, divide by 4, and what does that give you? Pi halves, right? So those are going to be my key points. So go a pi halves over here. That's going to be negative pi halves. A pi halves here. That'll be pi halves. This one will be 3 halves pi. This one will be 5 halves pi. And this one will be 7 halves pi. So there are my half pi's. Those are going to be my key points. Okay. Now, I think you'll notice this. Certainly later you'll notice it. I don't necessarily make my scales on my y-axis, vertical axis, the same as the horizontal. Because I want those horizontal to be at my quarter periods. Okay? The vertical, before we do the vertical is going to be your y here. What does sine usually go between on the vertical? Negative 1 to 1. Well, what we're going to do is multiply that by 2, so this is actually going from negative 2 to 2. So that's what I'm going to do, my vertical scales. We'll do 1, 2, negative 1, negative 2. Okay. Now I've got everything I need to go from. Okay? Now, where does sine usually begin? At 0. So it's still going to be 0. Even if you multiply 2 times 0, you still get 0. Okay, at pi halves, what's it usually? Pi halves, what's its usually value? It goes up to its at 1. But now we're going to multiply by 2, so that gets you up to 2. Okay? And then what happens at pi? It's what?
Intercept.
Okay, intercept. Okay, so it's back down to 0. At 3 halves pi, it goes down to its minimum, which is negative 2. At 2 pi, it's back at 0. Okay, right where it started. Okay, at 5 halves pi, where would it be? Plus 2. 3 pi, 0. 7 halves pi, minus 2, and 4 pi, 0. Okay? Remember, sine is 0 at the whole pi's is the maximum and minimum at the half pi's, in general. We need to go backward, so where will it be at negative pi halves? Negative 2, and at negative pi, back up to 0. Okay? I'm going to sketch it. And again, be sure these are nice, smooth curves, don't have any points in them. And they can be ugly curves like mine, or you can make them prettier. But that basically is what it looks like. They should be symmetric, but I don't draw two curves too well. Okay? There's your curve. Okay? Notice, for every period, it repeats itself. Okay? And let's just take it from here to here. And that repeats itself. Oh, wait, I'm sorry. Here to here. Not right. This one. This repeats itself. This is what I want. That repeats itself. Every period repeats itself wherever you start that period. Okay? Does that make sense? That's your first graph of a sine function. Okay? So any questions before I erase it? Okay? All right. Let's see how they do it. Note that y is equal to 2 sine x. Yeah, that's what we had. Okay? Is equal to, and another way to express this is 2 times the sine of x. We know what y is equal to sine x looks like. All you're doing is multiplying by 2. That, back in Math 112, we called a vertical stretch, when you multiply by a constant. Okay? That indicates the y values for the key points, will have twice the magnitude of those for y is equal to sine x. So that's why we have a vertical stretch. Now, rather than going from -1 to +1, it's -2 to +2. Your zeros stay your zeros. Okay, the intercepts don't change, because 0 times 2 is still 0. All right. So again, what we do, determine your period. Y is equal to 2 sine x is the same period as y is equal to sine x. That's 2 pi. Divide by 4. It gives you pi halves. So these give you your key points. Sine starts at 0 at 0, 0. Then at pi halves, you're at the max, which is now at 2 rather than 1. Your next half pi gets you to pi. You're back down to 0 again. The next half pi, you continue down to your minimum, -2. And then the next quarter period gets you to 2 pi. Half pi gets you to 2 pi. And there you're back to 0. The same place you were here, going the same direction you were there. So you get those plotted, and then just start repeating to the right and to the left. Okay? Now, be sure you connect them with smooth curves, okay? No jagged peaks or things like this. Make it nice and smooth everywhere. extending the curve in both directions over the interval from minus pi to 4 pi. Okay? So your one period would be, now they've shown both of them. They showed sine x here, that goes to plus or minus 1. And then when you double that, that double 0 is 0, double 1 is 2, double 0 is 0, double minus 1 is minus 2. So every point you're doubling, okay? Because that's what you're doing up there. So here's one period here, another period there, and then half a period back here, just like that. Okay? So that's how it looks. Smooth, continuous function. Any questions? Maybe not as pretty as mine, but no, I'm just kidding. Okay. All right. Goodness, I'm running out of juice. Okay, there is a checkpoint, and this is going to be 2 cosine x. So if you want to refresh your memory, as soon as you have an opportunity, do the checkpoint. If you can't quite figure them out, then go to larsonprecalculus.com. All right. Now, what I didn't like about example 1, it was changing the amplitude on it before we even talked about what amplitude was. So now we're going to talk about amplitude. We've already been talking about period. Didn't change the period, but it did change the thing we call amplitude. For the rest of this section, we're going to introduce 4 additional parameters. A, B, C, and D. Okay? And why they put them in this order, I don't know. I would do them in a different order. But A is going to be the thing you multiply the sign by, just like we multiplied by 2 before. B is going to be what you multiply your independent variable x by. Now, I don't like naming this one C. I'll tell you what I like to name it. It's the same deal, but it's and then they put D at the beginning. A, B, C, D, okay? Why didn't they put plus D back here, okay? Maybe so you wouldn't think it's part of the sign, but if you put the parentheses there, it's not. They put the D out front, okay? And also with cosine, A is the amplitude, B relates to the period, C relates to something else. By the way, if you remember, that's a horizontal shift because it's added or subtracted from x, and D is a vertical shift because it's added or subtracted from y. Now, and that's why I don't like naming that one C. I'll tell you how I like to do it. Of course, my background is physics, and it makes more sense to do it a different way in physics. Just slightly. It's just a little deal. Okay. So the constant factor A in y is equal to A sine x, just like the one we did, where that A was 2, acts as a scaling factor or a vertical stretch or a vertical shrink. If that A was 0.3, then that would be a shrink. If it was 7, that would be a stretch, okay, of the basic sine curve. So when the absolute value of A is greater than 1, that's a stretch, and when the absolute value of A is less than 1, it's a shrink, okay? Not a psychologist, but okay. The basic sine curve is shrunk. So its amplitude, or the max min, gets stretched or reduced. Okay. Make sense? All right. The result is that the graph of y is equal to A sine x now no longer ranges between minus 1 and 1. It ranges between minus A and A. Okay? Because that's what you're multiplying by. Before, ours was 2 sine x. That would range from minus 2 to plus 2. If this was 0.3, it would be minus 0.3 to positive 0.3. The absolute value of A is called the amplitude. So A could be negative. We don't really care about that. Its value, absolute value, is called the amplitude of the function. Okay? So y is equal to A sine x. The range of the function now shifts also. It's now going from minus A to plus A. Domain, you haven't changed anything there. That's going to be all real numbers still. But the range now is no longer plus 1 to minus 1. It's plus A to minus A, whatever that A value is. So here's the definition of the amplitude of sine and cosine curves. The amplitude of y is equal to a sine theta or y is equal to a cosine theta is represented by the magnitude of the a. Okay? Now, another way to look at that is half the distance between the minimum and maximum. Because if you think about it, the a is going up a or down a. So the difference between those two is twice the amplitude. Okay? So that's why they say half the distance between the maximum and minimum values. We'll use that in an applied problem later. So hang on to that. So the amplitude is absolute value of a. So amplitude is always a positive value, never negative, because it's absolute value. All right. Now, this seems like a weird place to put this, but it sort of does make sense. The graph of y is equal to negative f of x. Now, this is not necessarily trig function, negative f of x. Let's say that f of x looks like that. Okay? Negative f of x would look like this. You just negate everything. So that's a reflection in the x-axis of the graph of y is equal to f of x. So why did they bring that up? Well, what if this was a minus 3? What's the amplitude of that function? Y is equal to minus 3 cosine x? 3, okay? But what does the minus sign do for you? It flips it, okay? So whereas 3 cosine x would be up here, minus 3 cosine x would start down here. It flips it across here, and then everything is the same from there on, except flipped, okay? Exactly flipped. Okay, but the amplitude is still 3 for both of those functions. Does that make sense? Okay. Goodness gracious. I'm going to hazard a guess right now. I have a feeling after I finish this class and then finish the Math 112 class I started this morning because I got here late, I think I'm going home. Okay, yeah, I am running out of gas awfully quickly here. Okay. I thought it would be it. Okay. Because y is equal to a sine x completes one cycle from x equals 0 to x equal 2 pi. See, that hasn't changed any. It follows that y is equal to a sine bx. Okay, they threw in the b here now. That completes one cycle from x equals 0 to x equals 2 pi over b. In other words, one cycle is from bx to b 0 to 2 pi. Bx is 0 to 2 pi, well then x would be 0 to 2 pi over b. So that's how that becomes. I really don't like that way of expressing it, but it's true. It's perfectly correct. Now, we always use the b. Now, a can be positive or negative. B, we always do positive. We do not have b being a negative real number. I'm going to have to run down the hall and get a glass of water. I mean, a swig of water. I'm going dry on myself. I'll be right. Let me pause this just a moment. I'm sorry about this, folks. I need something. And what I pictured happening, I hope it was, I think it was, I pictured the chemicals attacking the cancer cells, you know, and that I had a battle going on inside. That's what I felt like, you know, earlier this week. I'm hoping that's what the extreme fatigue is. It may just be a reaction. I don't know. So I'm hoping that's happening again. So I'm hoping that tomorrow's treatment is not going to be a lot left for it to fight against. So I hope I'll feel a lot better next week. But we'll see. Okay. Sorry about the delay there. All right. So the period of a sine and cosine functions, if b is a positive real number, we don't ever let that be negative. A could be positive or negative, but b is always positive. then the period of y is equal to a sine bx, or y is equal to a cosine bx, the period now is 2 pi over b. That's what you do. A is related to the amplitude. It's the absolute value, amplitude is absolute value of A. The B is related to the period and how it changes the period. The period is now 2 pi divided by B. Okay. Now, I don't know if y'all remember this from your Math 112. Daniel was in my class, but the rest of you weren't. I used to always say, whatever you're doing with the y, it goes like you would expect. Whatever you're doing with x, that is absolutely backwards. Okay? I don't know if you remember that. Remember, if you do a add a y, you go up. Subtract the y, you go down. You add it to the x, you go to the left. You add to the subtract it, you go to the right. Okay? When you multiply by the y, by a big number, it stretches. A small number, it shrinks. When you multiply the x by a big number, it shrinks. And when you multiply by a small number, it stretches. That's why, because the b, the number, is in your denominator. So it's an inverse relationship. Okay? So that's why it's 2 pi over b. So that's what you have to remember. The period, when you have that sine bx or cosine bx, the period changes by, it was 2 pi, now you divide by b. 2 pi divided by b. So when the b is between 0 and 1, in other words, a small number, it has to be positive, okay, between 0 and 1, that is a stretch, okay? It's greater than 2 pi because you're dividing by a small number, horizontal stretching. And vice versa, when it's greater than 1, because it has to be positive, then it's a shrink. Okay. All right. Good deal. Similarly, okay, I said it before you printed it. Similarly, when b is greater than 1, the period of y is equal to a sine bx, or y is equal to a cosine bx, either one, is less than 2 pi because you're dividing by a number greater than 1. So it's going to make your period less. Okay. When b is negative, okay, here's what you do when b is negative. Okay? Remember what we said about sine of minus x? What kind of function is sine? As in even or odd? Odd function. So for an odd function, sine of negative x is negative sine of x. So that's basically all it's going to do is flip it across the y-axis, basically. Okay, but because cosine is an even function, cosine of minus x is cosine x, that's not going to change a thing to it. Okay, so we usually don't change the signs of the b, but when you do, it just flips the sign. It doesn't change the cosine. You're not going to see many of those, I hope. Okay, so let's do. They skipped example 2, so let's do example 2, and then we'll come back and do example 3. Oh, goodness gracious. Okay, on the same coordinate plane, sketch the graph of each function. Okay? It's going to be my coordinate plane. And example 2, both of them are cosine functions. So let's just start with, this isn't part of the problem, but let's just start this way. Y is equal to cosine x. We'll start with this. Y is equal to cosine x. Okay? Now I'm going to look ahead and make sure I get everything covered here. So let's do 1, 2, 3. Negative 1, negative 2, negative 3. Okay? Now, all of our x's are going to be the same, so we're not going to worry about those. So what would you suggest I do for the horizontal scale? Say again?
You said it's going to be the same.
Yeah. For these three that we're going to do, that one plus the two they give us in the problem. What we always do is we want to plot at least one period most of the time. So once you have a period, what are you going to do with it? Remember? Divide by 4. Remember? Take quarter of a period. And what will that be? Say again? Pi halves. Okay. So let's go 2 pi here. So we'll get 1 period there. And we'll do a minus 2 pi here. So I'm actually going to do 2 periods. Okay. So this one's going to be pi. That one will be negative pi. And this one will be minus pi halves. This will be minus 3/4 pi, 3 halves pi, sorry. This will be pi halves, and this will be 3 halves pi. Okay. That's how I usually start out, is try to get my quarter pi's in there. And since I decided to go both positive and negative, we will. So let's first do y is equal to cosine x. Tell me where that would begin. Say again, 1? Okay. 0, 1. Okay, and then where does it go from there? Down to 0, down to minus 1, back up to 0, and back up to 1. Right? Going the other direction, down to 0, down to minus 1, up to 0, and up to plus 1. I went a little too high there. So there is my cosine function. Kinda. Okay, something like that. All right, now what they actually ask us to do here, and I want you to give me a color. Red. Okay, you would have to pick the one that's hard to pick. Okay, there we got it. All right, so the A is going to be y is equal to 1/2 cosine x. What has changed for that one? The amplitude. It's now 1/2. Okay? Now, and it's positive. The A is positive. Amplitude's always positive, but the A is positive. So that means it's going to start not at 1, but at 1/2. So you'll do a 1/2 of that would be 1/2. 1/2 of 0 is still 0. 1/2 of negative 1/2 is negative 1. 1/2 of negative 1 is negative 1/2. 1/2 of 0 is 0. And 1/2 of 1 is 1/2. And going this way, 1/2 of 0 is 0. 1/2 of negative 1 is negative 1/2. 1/2 of 0 is 0. And 1/2 there. So here is the A graph. Okay, it's just a vertical shrink because the A is less than 1, right? All right, I'll need another color. Green, okay? The B one then is going to be y is equal to 3 cosine x. Okay, what will be different on this one? It's a stretch, and since it's a positive 3, it'll go up to plus 3, down to 0, down to minus 3, up to 0, and up to plus 3 again. Going the other direction, down to 0, down to minus 3, up to 0, and up to plus 3 again. So this, whoa, pretty ugly graph here. Something like that, really ugly. But there's example 2. The sort of darker graph there is just your original cosine function, and the red one is a vertical shrink by 1/2, and the green one's a vertical stretch by 3. Make sense? That's what amplitude does for you. All right. Okay, to erase? Okay. Because they don't show this one on the slides. But we're ready now for example. Oh, and by the way, there's a checkpoint after every example, so don't forget that. So let's do example 3. That's the one we're going to try to graph now. Okay? Now, my question to you, do you prefer to start with the basic function and then graph on top? So then if we are going to do that, let me get my pen back. Okay. Okay. So let's first do y is equal to sine x. The basic sine function. Okay. What will be my period for this one? 2 pi. Okay. So let's do a 2 pi here and a minus 2 pi here. Like this a minus pi, this a pi, this a pi halves, this a 3 halves pi, this a negative pi halves, and this is a negative 3 halves pi. Now, my scaling is not great, but it's that. Now, in this problem, both of these, okay, the one we're going to be doing and this one, what's our amplitude? 1. So let's just go from +1 to -1. See, like I said, I'd kind of let my scaling take care of itself. Okay. If I needed a 3, I'd make those 3s and then shrink the others. Okay. Now, where does a sine normally begin? At 0. So sine of 0 is 0. And then what does it do at 1/4 period? Goes up to +1, then down to 0, down to -1, and up to 0. Going in the opposite direction, it first goes down to -1, up to 0, up to +1, and down to 0. So there's my base function, my sine function. I don't draw curves too well. Okay, something like that. Now, what color do you want to do for the one they really wanted us to do? Say again? Green? Okay, green, it's green, they say, on the far side of the hill. Okay. Now, so this one will be green. Now, here's how I like to start these, even though it's not necessary in this one, but I like to do all these when I am going to do it. I like to identify my parameters. In this one, what's your A? 1. Okay, what's your B? Not quite. It's 1/2. It's the coefficient of the x. That's your B. They don't have a C or a D, so those are both zeros. Okay, the A is 1, meaning amplitude 1. We're not going to change the amplitude at all. Okay? But what does B influence? The period. And how does it influence the period? The period is 2 pi over B. Okay? So that would be 2 pi over B, but B is 1/2, right? Which would be the same as 2 pi times 2 over 1, which is 4 pi. Whoa, I blew it, didn't I? Okay. Yeah. Okay. We can still handle this, but now the period should be 4 pi. And I did only 2 pi in each direction. But that gives me a total of 4 pi. So, what is the next thing we do? Once we know what the period is, we do what? divide by 4. So 4 pi divided by 4 is then pi. So 4 pi divided by 4 is pi. So that's going to be my quarter period. Okay? Now sine starts at 0, so we're fine. But now this function, this one right here, it reaches its maximum at pi. So that goes up to here, right? And it goes back down to 0 at another quarter period, right? So that will be at 2 pi. Going in the opposite direction, it reaches a minimum at minus pi and back here. So here's how the new graph looks. Okay? What is that? Because the b is a small number, we have a horizontal stretch. Okay? That is one period. I should have really looked ahead when I started this thing and drawn from 0 to 4 pi and negative 4 pi to 0. And then our base function would have had 2 periods between here and 4 pi. This one would have 1 period. So it's a horizontal stretch. Make sense? Okay. Amplitude didn't change. It went from +1 to -1, just as normal. The period is what stretched because the b was smaller than 1. Okay. All right. Sorry about that. If you look in your book, you'll see. Oh, wait. They do show it here. So let me not do that. Can I erase this one? Okay. They're going to look ahead better than I did. And the amplitude is 1. Good to notice that. The b is 1/2, so the period is 2 pi over b, which is 2 pi over 1/2, which is the same as 4 pi. I like to put the extra step in there, 2 pi times 2 over 1, which is 4 pi. Now divide the period interval, 0 to 4 pi, into 4 equal parts, just like Daniel said. Divide by 4, and that will then give you pi, 2 pi, 3 pi, and 4 pi as your key points. And sine starts at the origin, so the intercept 0, 0. At your first quarter period, which is pi, okay, because divide 4 pi into 4 equal pieces, that's going to be pi. You go up to your maximum 1, down to 0, down to -1, and up to 0. Okay? So this was your sine function. If I had done the 4 pi like I should have, period of 4 pi, for this function, 0 pi, 2 pi, 3 pi, 4 pi, negative pi, negative 2 pi, blah, blah, blah. Your sine function would have had 2 complete periods from 0 to 4 pi. One at 0 to 2 pi, one at 0 to 2 pi to 4 pi. Another complete period here, 0 to negative 2 pi. Okay? But this one, your period is now 4 pi, so you reach your peak at 1/4 of that interval, which is pi, back down to 0 at 2 pi, back down to -1 at 3 pi, and back up to 0. One complete cycle in the period of 0 to 4 pi. And another half cycle over here, going down to -1, up, back up to 0. Make sense? Horizontal stretch because your b is less than 1. All right. There is a checkpoint here, well worth your effort to do. Okay, next thing we're going to do well, let me just at least introduce it. We're not going to have time to finish. Sorry, I had to take a break in the middle. Translations of sines and cosine curves. Now we're going to do one more parameter, and this is going to be our C. And again, I really don't like their placing them this way, but this is what the book does, so get used to it. Y is equal to A sine open parentheses, Bx minus C. It creates a horizontal translation or a shift on the basic sine or cosine curve. Now, I'll tell you, I don't know. We're going to have to repeat it all again because this is not the simplest. So let's just stop here. We'll pick up and go from there next time. Sorry that I had all the blah, blah, blah at the beginning of class. Now, somewhere I had a pencil. I know I brought a pencil in here because I used it in my last class. Did someone borrow it? What's that? Okay. Let's see. I do need to make a mark. Oh, there it is. There it is. Hiding. Okay. We'll pick up with translations of sine and cosine curves here. That's where we'll go from next time. Okay. Let me give you some homework exercises. I know you wanted some of those. So you can do any of the odds 5 through 11. All those odds are at calcchat.com. Number 7 is at calcview.com. Okay? And then do any of the odds 13 through 19. They're all at calcchat.com. None of them are at calcview.com. Okay, sorry, back up. Just do 13 and 15. Okay, because the 17 has a translation we haven't done yet. Okay, we'll stop right there then. All right, good deal. I hope I'll be here Tuesday. I plan to be here Tuesday, but watch Blackboard and email just in case I get wiped out again next week. I would not have thought I'd have gotten this tired today either, but I did. So, all right, good deal. We'll have a good